Hi everyone, welcome to part 2 of trigs. This tutorial will deal with quadrants as well as solving simple trig equations. So the first thing we are going to look at would be quadrants. There are 4 quadrants in a circle, and as you recall from part 1, pi radians equal 180 degrees. So if we divide a circle into 4 parts and we are looking at it in terms of degrees, this side is called our first quadrant, and this part of it involves degrees from 0 degrees to 90 degrees. And in terms of radians, 90 degrees is the same as pi over 2 radians. So that means angles in this quadrant would be from 0 radians to pi over 2 radians. This is a second quadrant, and theta or angles in this quadrant lies between 90 degrees and 180 degrees, and in terms of radians, theta would lie between pi over 2 radians and pi radians. So again, pi over 2 radians would be the equivalent to 90 degrees, and pi radians equal 180 degrees. Next, we have our third quadrant, where theta would be angles between 180 degrees and 270 degrees. And in terms of radians, that would be between pi radians and 3 pi over 2 or 3 over 2 pi radians. Next, we have our fourth quadrant, which theta lies between 270 degrees and 360 degrees. In terms of radians, that would be between 3 pi over 2 radians and 2 pi radians. And the quadrants are always in this order. This one is always first, going in an anti-clockwise direction. This is second quadrant, third quadrant, and fourth quadrant. Another thing that we need to know about quadrants is that they have this property which tells us which trig functions can be positive or negative. So in the first quadrant, this is where all our trig functions are positive: sine, cos, and tan. The second quadrant, only sine is positive. That means the other two functions, cos and tan, would be negative here. The third quadrant, only tan is positive, which means the other two functions, sine and cos, would be negative here. And then we have our fourth quadrant, in which cos only is positive, so therefore the other two, which is sine and tan, would be negative here. So this written in green indicates which functions are positive in these quadrants. Whichever functions are not listed means that it's negative there. So we need to remember A, S, T, C in an anti-clockwise direction. We can use any phrase that can help us to remember this. So for example, all students take calculus, or even all students take chemistry, or any other phrase that can help you to remember the order of the letters A, S, T, C. So just to go over it briefly one more time, this quadrant, A, means that all the trig functions here, sine, cos, and tan, are positive. S means sine alone is positive here. T, tan alone is positive in the third quadrant. And C, in the fourth quadrant, cos alone is positive. Now we have our angles. In a few minutes, when we are solving simple trig equations, we'll see where these come in. So we have three trig functions that we are looking at: sine, cos, and tan. So the first one, we are going to look at solutions of sine x equal k. So we have two cases when k is a positive number or a negative number. So let's look at the first one. If sine x equal k, where k is greater than 0, that means that k is a positive number, then the solutions are in the first and second quadrants. So if you look at a diagram, this is similar to the previous diagram without the additional information. We know that this is first quadrant, second, third, and fourth now. So ASTC is written there again. So A, all of them positive here, and S means sine is positive here. So going back to our note, where k is a positive number, then the solution would be in the first and second quadrants. It's important to know which quadrants are relevant when we have to find the value of x in solving equations. Next, our second case is when k is negative. So if sine x equal k, where k is less than 0, then the solutions would be in the third and fourth quadrants. So we are looking to figure out which quadrants would give our negative values. So here we see that from before, if these two quadrants are where sine is positive, then the other two quadrants would be where sine is negative. So in the third quadrant, tan alone is positive here. That means other trig functions like sine would be negative. Similarly, in the fourth quadrant, cos alone is positive here, so other trig functions such as sine would be negative. So the two quadrants where sine is negative would be these two, third and fourth. Next, we are going to look at our first example. Find all the angles between theta and 360 which satisfies the equation sine x equal 0.866. So our solution would be to start off with our equation which is given. Then to solve for x, we would have sine inverse of 0.866. When we put that into our calculator, we would have x equal 60 degrees, and that gives our principal solution, or alpha, which is our first quadrant solution. So here is where the angles that were written in the previous diagram comes in. So first we are looking in terms of degrees. So what I have written in blue would be what we are going to use to calculate the angles or the solutions where we have it in degrees. So alpha here always represents our principal solution or our first quadrant solution when sine is positive. So the 60 degrees falls in the first quadrant, and that's our principal solution. But 0.866 is a positive value, which means we need to consider the quadrants where sine is positive. So we know from before the ASTC circle, sine is positive in the first and second quadrants. So from here in our second quadrant, to calculate x, our angle would be 180 minus alpha. So second quadrant, x equal 180 minus alpha, which is equal to 180 minus 60, which is equal to 120 degrees. And this is known as our secondary solution. So our answers for this part of the question, would be x equals 60, which is our first quadrant, and second quadrant solution, x equal 120. Therefore, the solutions are 60 degrees and 120 degrees. Now we are going to look at solutions of cos x equal k. So again, just as before, we have two cases, which is when k is a positive number or when k is a negative number. So the first case, if cos x equal k, where k is greater than 0, that means that k is a positive number, then the solutions would be in the quadrants where cos is positive, and that would be in the first and fourth quadrant. So again, we're looking at our diagram, the ASTC diagram. So here all of them would be positive, and this quadrant cos would be positive. So our solutions where k is a positive number would lie in the first quadrants and fourth quadrants. Our second case would be when k is negative. So if cos x equal k, where k is less than 0, then the solutions would lie in the quadrants where cos is negative, and that would be in the second and third quadrants. So if these two are where cos was positive, then the other two would be where cos is negative. So here sine alone is positive, tan alone is positive, which means in these two quadrants cos is negative, and that will be used to determine our solutions when we have to solve for the value of x, as seen in our next example. Find all the angles between 0 and 360 which satisfies the equation cos x equal 0.76. Solution: if cos x equals 0.76, then x would be equal to cos inverse of 0.76, which gives us 40.5 degrees, and this is called our principal solution, alpha, which is our first quadrant solution. So, since 0.76 is a positive number, our solutions would lie in the quadrants where cos is positive, and from our diagram we can see that in the first quadrant and the fourth quadrant cos would be positive. So the answer 40.5 is our first quadrant solution, and then we need to find our solution in the fourth quadrant. So in the fourth quadrant, I am using what is written here in blue, 360 minus alpha. So x equal 360 minus alpha, which is 360 minus 40.5, which is equal to 319.5 degrees. And this is our secondary solution. Therefore, the solutions of x would be 40.5 degrees and 319.5 degrees. Now we are going to look at our third trig function, tan x equal k. So just as the other two before, we have two cases where k could be a positive number or a negative number. So if tan x equal k, where k is a positive number, then our solutions would be in the quadrants where tan is positive. And we can see from our diagram, tan would be positive in the first quadrant and the third quadrant. If tan x equal k, where k is less than 0, that is when k is negative, then the solutions would be in the quadrants where tan is negative, and that would be in the second quadrant and the fourth quadrant. Let's look at an example. Find all the angles between 0 and 360 degrees which satisfies the equation tan x equal minus 8.14. So in this case we have a negative value. So tan x equal minus 8.14, and to work out the angle in the first quadrant we use tan inverse of positive 8.14. We are just using the positive values here, and then we would look at which quadrants tan is negative. So tan inverse of 8.14 will give 83 degrees, but this is our answer if tan was positive. So in this case, 83 degrees is not our solution or our principal solution, but it is now called a reference angle because it can be used to find the angles or the solutions in which tan would be negative. So tan would be negative in the second and fourth quadrants. So we have the second quadrant solution from our diagram is calculated by using 180 minus alpha, and that would be 180 minus 83. Again, alpha is this angle, our reference angle, which gives 97 degrees. And then in the fourth quadrant, x equal 360 minus alpha, which would be 360 minus 83, which is equal to 277 degrees. Therefore, the solutions are 97 degrees and 277 degrees. So far, these are just basic trig functions that we have learned, trig equations, in which we are going to use this knowledge to apply it to further trig equations. But before we do that, we have a table here which shows us the trig ratios of special angles. These special angles mean that they can be expressed in third form. So this applies to the angles 0 degrees, 30 degrees, 45 degrees, 60 degrees or 90 degrees. And in terms of radians, 30 degrees would be pi over 6 radians, 45 degrees would be pi over 4 radians, and 60 degrees would be pi over 3 radians, 90 degrees pi over 2 radians. So this table is read as sine of 0 would give 0, sine of 30 degrees would give a half, or the same sine of pi over 6 radians would give a half. Sine of 45 degrees would give us root 2 over 2. Sine of pi over 4 radians would be root 2 over 2, since 45 degrees and pi over 4 radians would be the same. Sine of 60 degrees is root 3 over 2. Similarly, sine of pi over 3 radians would also be root 3 over 2. And then sine of 90 degrees is 1, or sine of pi over 2 radians is 1. If we are working out sine, cos, and tan of any angle, in our calculators, it is important to note that the mode of the calculator affects your answer. So if we are working out sine of 30 degrees, your calculator must be in degrees mode. If your calculator is in radians mode, then you will not get the correct answer. Similarly, if I'm working out sine of pi over 6 radians in our calculator to get a decimal value or fraction, then we need to have it in radians mode. If we put in sine of pi over 6 in degrees mode, we are not going to get the correct answer. So pay attention to whether your angle is in degrees or radians and adjust the mode in your calculator accordingly. So similarly, for cos and tan, it is read the same way as explained for sine. Now note, this table can also be used for the inverse trig functions as well. So for example, from the table where we had sine of pi over 6 radians is equal to a half, then if I have sine inverse of a half, that would give us pi over 6 radians if we want our answer in radians, or 30 degrees if our answer is requested in degrees. And normally a question would specify whether your answer should be expressed in degrees or radians. So this table needs to be learned for exams, and there's another way that we can learn it. You can memorize the table, or we have an interesting diagram here that we can use. However, this diagram is only helpful for sine and cos. So we can see from this diagram, if we are going from left to right, that gives us our third form for sine. So the thumb on the left hand in red, all the red values are the sine values. So for 0, 30, 45, 60, and 90 in ascending order. So sine of 0 is root of 0 over 2, which is just 0. Then sine of 30 is root of 1 over 2, 45 root 2 over 2, 60 root 3 over 2, 90 root 4 over 2. Now obviously we know that the square root of 0 is just 0, square root of 1 is just 1, and so on. But the reason it's written this way is so that you can remember the pattern: square roots in the numerator, 2's in all the denominators, and in the square roots we have 0, 1, 2, 3, 4. Similarly, cos goes in the reverse direction from the little finger backwards to the thumb, and the values here are written in blue. So for cos, it's very similar, where we have the square roots in the numerator, all the denominators are 2, and in the square roots we have the numbers 0, 1, 2, 3, 4. So you can learn either this one or the table, as long as you know what the third values would be for these trig functions. Next, we have trig equations involving factorization. So we are going to need our prior knowledge, which we have looked at just now, in terms of what quadrants mean, how to find the values, where sine, cos, and tan will be positive or negative, and in which quadrants, as well as our table, which helps us figure out what our answers would be in terms of radians. So our example: solve for theta in the equation 2 sine theta cos theta equal cos theta. Notice there's no sign in between such as add or subtract here, so it's understood as multiplication. So this is 2 sine theta multiplied by cos theta equal cos theta. And at the end we have this part of it, which is very important, where theta is between 0 and 2 pi radians. This is telling us that when we solve, our answer is expected to be in radians. So our solution, we start off with the equation that is given. Next, I want to have 0 on the right hand side, so we will have 2 sine theta cos theta minus cos theta equals 0. Now we notice that both terms has a common factor here, which is cos. So we have our cos value here and here. So if we factorize cos, we would get cos theta, open brackets, 2 sine theta minus 1 equals 0. So just as when we solved quadratic equations, the same applies here. So if cos theta by this bracket 2 sine theta minus 1 gives 0, then either the cos theta is equal to 0 or the 2 sine theta minus 1 is equal to 0. So now I'm going to separate that into two parts and look at each one separately. So if cos theta is equal to 0, then theta would be cos inverse of 0, and in terms of radians, that would give us pi over 2. This is obtained from our table before. So here where we have cos inverse of 0, if we look at the table, cos of pi over 2 gives 0. So cos inverse of 0 will give pi over 2. So that value here would be our first quadrant solution, our principal solution. And for cos theta equals 0, the solutions will lie in the first and fourth quadrants as shown in this diagram as from before, A, S, T, C. Cos would be positive, first and fourth. So this pi over 2 is our first quadrant solution, and in our fourth quadrant, theta would be calculated using 2 pi minus alpha. So just looking back at this diagram before we had looked at what I had written in blue, which is used when we had degrees. But when we have radians, we are using what is written in red. So when we have alpha being in radians, in our second quadrant, the solution would be pi minus alpha, third pi plus alpha, and fourth 2 pi minus alpha. So in this case, our fourth quadrant solution would be calculated using 2 pi minus alpha. So where alpha is a pi over 2. So theta equal 2 pi minus pi over 2, which gives us 3 pi over 2, which is the same as 3 over 2, pi being separate. Alright, so usually our answer would be written or expressed as an improper fraction. It is not necessary to change to mixed numbers. So that's it for this part of the question where we had cos theta equals 0. Now on the side we had our second part where we had the 2 sine theta minus 1 equals 0. So we have 2 sine theta equal 1, and then sine theta would be equal to a half. So theta would be sine inverse of a half. Now let's look at this table one more time. So we have sine of pi over 6 is equal to a half. Then we have sine inverse of a half will give us back pi over 6. So here we have sine inverse of a half equal pi over 6. So since we have sine inverse of a half, which is a positive number, the solutions will lie in the first and second quadrants, since these are the two quadrants where sine is positive. So pi over 6 is our principal solution, or our first quadrant solution, and then for our second quadrant we are using the formula here, pi minus alpha. So theta equal pi minus alpha, which is pi minus pi over 6, which is equal to 5 pi over 6. Therefore, the solutions for this equation that we started with would be all four values, the pi over 2, the 3 pi over 2, pi over 6, and 5 pi over 6 radians. Let's look at another example. Solve for theta in the equation sine theta equal to tan theta, where theta is between 0 and 2 pi. So again, this indicates that our solutions are expected to be in radians. So before we move on, I want to introduce you to something called an identity. Identity comes from the word identical. So we have our first identity that we are learning in trigs, which is tan theta. This symbol with 3 lines means is identical to sine theta over cos theta. So tan theta is identical to sine theta over cos theta, which means that later on when we are doing equations, solutions, and something called identities, where we go into it further, we will see that this comes in quite useful. So solution, sine theta equal to tan theta. We are looking at equations that involve factorization, and factorization means that terms would have a common factor. But sine theta and tan theta, as it is, does not have a common factor. That is why we have to introduce our identity. Tan theta equals sine over cos. So if I express tan theta here as the sine theta over cos theta, our 2 is just here from before, then now we can see that we have terms in common if we rearrange. So trying to get 0 on the right hand side, I will now have sine theta cos theta equal to sine theta. Then this will give us sine theta cos theta minus 2 sine theta equals 0. So now we see that we do have a common factor in our terms. We have a sine theta in this term and a sine theta in this term. So that gives us sine theta open bracket cos theta minus 2 close bracket when we factorize, and writing that equal to 0. So similar to before, if we have this being equal to 0, then either sine theta equals 0 or cos theta minus 2 equals 0. Let's look at the first case. So if sine theta equals 0, then theta would be sine inverse of 0, which is just 0. So let's look back at this table. If sine of 0 is 0, then the opposite also applies. Sine inverse of 0 will give us back 0 as well. And also note that on the line representing 0 degrees in a circle, that's also the same line that represents 360 degrees. Since 360 degrees represents a complete revolution, it will take you back right to where you started at 0 degrees or 0 radians. Also same applies for 2 pi. 2 pi radians is equal to 360 degrees. So the 2 pi radians also fall on the same line as 0 radians. So since sine of theta equals 0, it's considered positive value in this case because it's not negative. The solutions would lie in the first and second quadrants. So this value of 0 and 2 pi, both of them are solutions which would lie in our first quadrant. So these are our principal solutions. And then for our second quadrant, we are going to use pi minus alpha from our diagram. So second quadrant, theta equal pi minus alpha, which is equal to pi minus 0, which is just pi radians. Now let's look at the second part, cos theta minus 2 equals 0. If we have cos theta minus 2 equals 0, then cos theta equal 2, so theta equal cos inverse of 2. If we put this into our calculators, we will get error. So that means that no solution exists for this part of our question. So therefore, our only viable solutions would be what we got on this half of it, which would be when theta is 0, 2 pi, and pi radians. So far for this tutorial, we have learned a lot about quadrants, what they are used for. We have learned important information in terms of which quadrants our functions would be positive and negative, how to calculate our principal solution, secondary solution, which quadrants to use, which of these formulas to use that I have written in blue and red. We have also been introduced to our special angles here, which can be expressed in surd form. Then we went on to solving simple trig equations and also equations which involves factorization. So please review everything that we did, ensure that you have a complete understanding of what we have done so far. We still have one other video to complete trigs, so look out for part 3 coming soon. So just to ensure that you have understood what was done, we have one question here to try. So please review everything that we have done and attempt the question in this exercise. Thank you for tuning in. We will continue in part 3.